All right, this is lesson 5 in chaos, fractals and dynamics, based on the little book by Dr. Robert L. Devaney. And what we are going to do today is go through a proof of why certain points at certain values of C, we go from escaping to not escaping to an eventual single cycle or an eventual fixed point, and also and that would be at the value of 0.25, and we're going to prove that's the place that it changes, and why at negative 0.75 we switch over from an eventual single cycle to an eventual two cycle. We've seen it graphically. If you watch this, we've got escaping here, starting with a seed of 0. Notice the last value is infinity. But as we move down, at the moment that the curve and the line y equal x become tangent to each other, that's the place where we no longer escape, and in fact we are converging towards some number. In this case, 0.49803 is what we get after 500 iterations. Looks like it's probably converging to 0.5. And from then on, for quite a while, we get convergence. Even that is convergence until we reach negative 0.75, and then we're going to get, instead of single cycle convergence, we get a two cycle. So the first thing we want to do is figure out why this 0.25 is special. We're going to do the math there. If you don't get it, it's not a big deal, but if you do get it, it's really nice. So let's think about this for a minute. If you have a fixed point, it means when you plug in x and you get y, and then make y equal x, these things don't change. And the only way that's going to be true is if you have f of x equal x, because then when you plug x back in, whatever that value of x is, you're going to get the same result. Okay, and so what we want to do is find out when this is true. When you have a one cycle, basically, when you have, a fixed point where things don't change, and that will be where y equals x. X squared plus c equals x. And what I'd like to do is solve that equation for x. X squared minus x plus c equals 0. And I can solve that equation for x using the quadratic formula. So let's do that right now. There's our old friend, the quadratic formula. And we're going to plug in negative b. b is negative 1. It's the coefficient of x, so that would be 1. Plus or minus b squared would be negative 1 squared, which is 1. Minus 4a. a is the coefficient of x squared, which is 1. Times c, and c is in fact c. Over 2a. 2 times 1 is 2. And there we have the equation of x for a fixed point. Now, the question then comes, when is this equation valid? And since right now we're dealing with real numbers, it's only going to be valid when this is a real number. So, the only way we can have convergence to a fixed point, or just a fixed point, or convergence to a fixed point as well, is if what's under the radical here must be greater than or equal to 0. Okay? If it's less than 0, we're going to get imaginary numbers. When we get the imaginary numbers, that's when we're getting the escaping. So, if 1 minus 4,3 is greater than or equal to 0, that means negative 4c is greater than or equal to negative 1. Dividing both sides by negative 4, we get c is less than or equal to, you remember you switch around that inequality, less than or equal to 1/4. And so what we learn is there are going to be answers for this that are real when c is less than or equal to 1/4. 1/4, of course, is 0.25. So remember, we started with c larger, and we had stair-stepping off to infinity, and 0.25 is the boundary line, and right at 0.25 we get our single cycle. In fact, 0.25 is a fixed point. X equals 1/2, which was what we saw. It was moving towards 1/2. And so that means that we found the fixed point, 0.25. Now, c is less than 0.25, but what happens when we hit negative 0.75? Well, it's going to be a little more interesting and a little more complex. So let's try to do that right now. Okay, when you have a fixed cycle, f of x equals x. But when you have not a fixed cycle, but a two-cycle, f of x equals x, because it takes 2 cycles to get back to where you started. So I need to write that some way. Let's see if we can do that. F of x. Let's rewrite f of x as x squared plus c. So f of x will equal f of x squared plus c, and f of x squared plus c will equal the thing in parentheses, x squared plus c squared plus c, and that has to equal x. And so all I have to do is solve that equation for x to find out where I have a 2-cycle, an exact precise 2-cycle. So let's look at that right now. If I multiply all this stuff out, and right here, here's what I get. X to the 4th plus 2cx plus c squared plus c equals x. Rearranging that, I get that, and I didn't have to put my x squared here before. I've got it in there now. Okay, and I want to solve that, and that's a little trickier to solve because, of course, it's not a quadratic; it's a quartic. Okay. Fortunately, I've got a nice little gimmick I can use to solve this. Because I know that one of the solutions to this already comes from the work that I did previously. And what I mean by that is, I know that x squared minus x plus c equals 0 is a solution to this. Because if it's a 1-cycle, then it's also going to be the same on the 2nd cycle. So that those 2 solutions, or the solutions associated with that, are built in here. So I'm going to take x squared minus x plus c, I'm going to divide it into x to the 4th plus 2cx squared minus x plus c squared plus c. And I know that's got to go evenly into it, because if it's a single fixed point and you do it again, it's still a fixed point. So the single fixed point also gives you the same, will be a solution to the 2-cycle equation. So I'm going to do that long division, and here we go. X squared goes into x to the 4th, x squared times x squared times x to the 4th minus x cubed squared. And I subtract that, and I get x squared plus cx squared, and bring down the negative x. And now I'm going to divide x squared into x squared. Oops. Sorry, this is not an x squared. This is an x cubed. See, it comes from that baby right there. So now I'm going to divide x squared into x cubed, and I get x. And x times x squared gives me x cubed, and x times negative x gives me negative x squared. And x times c gives me plus cx, and I do this subtraction, and here's what I get. Okay, and now I'm going to divide x squared into c plus 1 times x squared, and I get c plus 1. And multiplying it out, I get here c plus 1 times x squared minus c plus 1 times x plus c squared plus c. And lo and behold, that does subtract out and give me a remainder of 0, which I knew would happen. And now, basically what I've done is factor this equation. This factor I knew was going to give me a solution. I already knew about that solution, and now I'm going to take the x squared plus x plus c plus 1, set it equal to 0, and solve. And plugging into the quadratic formula, this is what I get. And this solution is not going to be real unless that's greater than or equal to 0. 1 minus 4c plus 1. So I take 1 minus 4c plus 1. That's greater than or equal to 0. And I move the negative 1 over to the other side. I get negative 4 times c plus 1. It's greater than or equal to negative 1. So c plus 1 has to be less than or equal to 1/4, which means c has to be less than or equal to negative 0.75. And we've just shown that negative 0.75 is the boundary between a 1 cycle and a 2 cycle. Now, going further on with this, the arithmetic, the algebra gets a little more complicated. Actually, it gets a lot more complicated. But there's the principle of the thing. That's how we analytically find those points. So that's about all we're going to do on this. If you understand that, that's good. If you could reproduce it yourself, that would be great. And if you're still a little confused about it, that probably won't affect your understanding of the real mathematics that's behind all this, which is a lot easier to see with the various software tools that we use. So do not despair if you don't get this. That's all for now. And next lesson coming up.